morning everyone. This is Vijayasri, working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discuss about parameter passing mechanism in C. Overview of the session, parameter passing techniques in C. There are two types of methods. One is the call by value and the other is call by reference. Then, parameter passing in C. See, the parameter passing in C is that when a function gets executed in a program, the execution control transferred from calling function to called function. That means the execution control transferred from calling to called function. Suppose to declare a function, we have to use a return type. Function name, let us suppose here I am considering function name as fun, and here we'll pass the parameters. Here I am taking the parameter as int, which I am passing only one parameter. Then main. In a main, we'll call the function with the function name, and then suppose here I have used one argument, so here I am considering a. So when we call the function, the control goes to function definition. Function definition should match with the declaration void fun argument in. So here it is called the calling function. Now here this is called as the called function. So the execution control transferred from calling function to the called function. And then finally, once it is done with this block of statements, again the control goes back to the calling function. So while calling in this way, the called function may carry one or more data values. These data values are called as parameters. So here we have a which is carrying one parameter from calling function to the called function. So these data values are called as the parameters. So parameters are the data values that are passed from calling function to the called function. So there are two types of parameters, actual parameters and formal parameters. Actual parameters are specified in the calling function. So this is the calling function. These parameters are called as actual parameters. And the parameters which are in called function, this is the called function. In this we have a parameter called n. This is called as the formal parameters. Now parameter passing in C language, in C programming language, there are two types to pass parameters from calling function to called function. One is call by value and the other is call by reference. In call by value, parameter passing method, the copy of actual parameters were copied to formal parameters. So the changes made on the formal parameters does not affect on the actual parameters. We'll see the example. See here I consider a function name called change. The function name is called as change, which is having a list of arguments are of 2. And then program execution starts from main section. Then in a main, so consider here we have a main. In a main, we have a 2 variables called AB. AB are the 2 variables of type integer. Suppose this is a memory for A and this is a memory for B, and in A is assigned with the value 10, is initialized with the value 10. So now A value is 10 and B value is 20. So here we have a B. Now in a sequence we have a print statement. So consider it as a output console. Here we have a console window which I am printing AB values. Those are 10, 20. So here we can see. Then change, where change is a function name A comma B. This is the function call. I am calling the function. Here I am passing 2 parameters. Those are A and B, where A value is 10 and B value is 20. So when we call the function, the control goes to the function definition. So definition should match with the declaration, that is the return type, yes, void, then the function name, change. Then here we have list of arguments, those are of parameters are of 2. The copy of actual arguments are copied to formal arguments. Here in a function call, those arguments are called as the actual arguments, and in the function definition, those are called formal arguments. So copy of actual arguments are copied to formal arguments. So here we have a function called change like a main. There also we have a 2 variables, those are A and B. These are copied. So the value of A here is, is 10 and B is 20. So here we have a value as 10 and B value as 20. But in a function definition, what I am doing is I am changing the values. Like A value is with 5 and B value is with 6. So after changing the values, because let us suppose these in main, the A is stored in address of 1000, suppose. So it is stored at 2000. And in a function definition, A value is stored at suppose 3000 and B is at 4000. So basically address is in the form of hexadecimal form. For simplicity purpose, I have considered these are the addresses of those memory locations. Now, in a function definition, I have changed A value with 5 and B value is with 6. Now I am trying to print the values, so it will be printed as 5 and 6. So after printing, I have reached the end of the function definition. So again the control goes back to the function where we called. So it will return back here. So after returning back in a sequence, we have one more printf statement, that is A comma B. These A comma B are present in the main function, which are local to that main function. Here A, B are local to this function called change. Whatever the changes made in the function definition, that will not affect in the variable, that will not affect in the function main, because I have changed the values in subprogram in a function definition. When it returned back to the main function, there the AB values are 10 and 20. So whatever the changes made here, those will not affect in the main function. So we'll print 10 and 20. So here, that is the changes made on the formal parameter does not affect the values, of actual parameters. Here I have changed the values, but those will not reflect on the actual parameters. To overcome this, we are using a call by reference technique. So here we have one more example called swapping of two numbers using a call by value. So here AB values are 10 and 20. So when we call the function, A value is 10 and B value is 20. These values, copy of these values are copied to formal parameters. So here A value is 10 and B value is 20. Using a temporary variable, I am swapping the values of A and B. So here A becomes 20 and B becomes 10. After swapping, when the control goes back to the calling function, these effects, whatever these changes, whatever I did in a function definition will not reflect in a main function. So in this main function, the values of AB are 10 and 20 only. So for this, we are using a call by reference. In call by reference, parameter passing method will pass memory location address of actual arguments is copied to formal parameters. In call by value, value is copied. But in call by reference, what I am doing is, I am passing the memory location address of actual parameters address of actual parameters are copied to formal parameters. Here I am not passing the value of actual parameters, I am passing the address of actual parameters. So to store that address, we need a pointer variable. So pointer is having a property that it can store address of another variable. That means in call by reference parameter passing method, the address of actual parameters is passed to the called function using a pointer variable. So by passing this, whatever the changes made in formal parameters will affect the values of actual parameters. Now coming to the example. So consider the example for call by reference. Here I consider swapping of two numbers using a call by reference. So function declaration is void swap. In call by reference, we have to pass address as the argument. So address is represented with the pointer variable. Then always the program execution starts from main section. So consider here we have a main. So in a main we have a local variables called A, B. So some memory is allocated to the variable A and some memory is allocated to the variable B. So here we have A value as 10 and B value as 20. So before swapping AB values are 10, 20, that is printed. Then after that I have called this function, calling function. Calling function syntax is just a function name, but here I am passing the address as the argument. So address is represented with the operator called ampersand address of. Then swap and A and B. Let us suppose the address of this A is 1000 and B is of 2000. So here we have 1000 and B is 2000. That means here I am not copying the values of A, B. I am copying the address of their memory locations. So when we call the function, the control goes to function definition. So here we have two variables called int A and B. Those are the pointer variables. Swap is a function like a main. So in a swap we have two variables A, B. But in A we have address of A and address of B. Where address of A here I consider as 1000 and B I consider as 2000. So here we have 1000 and here we have 2000. That means indirectly this is pointing to here and this is pointing to here. Now temp is equal to, here I consider one more variable called temp. Using a temporary variable we have to swap those two values. So temp is equal to star A. Star A. Star A is nothing but star address of A, where address of A is 1000. So in address of 1000, where is address of 1000? Here we have, what I am doing is I am storing that in a temp first. That means 10. So then address of A is equal to address of B. So address of A is nothing but 1000 is equal to star B, that is 2000. So in star 2000, this is the 2000 where star is the dereference operator. That means the value in that memory location is 20. That is stored in A. So that means here we are storing the value 20. Then next star B is equal to temp. Star B means star address of B, where address of B is 2000. 2000 is equal to temp. Already in temp we have 10. That means in address in 2000. In 2000 we are storing the value 10. So after reaching end of the function, the control goes back to the calling function. And after calling function, we have one printf statement called address of ampersand d, b is equal to, after end of the function, the control goes back to the calling function. And in a sequence, we have a printf statement. Printf after swap a is equal to %d, b is equal to %d, comma a, comma b. But here we are copying the address of the variables, and whatever the changes made in the formal parameters, those will affect in the actual parameters. So here it will print as 20 and 10 because by accessing their memory location, I have changed the values. Okay, so now call by value, whatever the changes made in formal parameters, that will not reflect on actual parameters, but in call by reference, whatever the changes made in formal parameters, that will affect in actual parameters also. In the next session, we'll discuss about dynamic memory allocation. Thank you.